Welcome to Blue Pen Land here. We're going to do, this is another two-part kinematics problem, right? So basically this is the, part one, right? We're going to solve this. Ultimately we're going to get the acceleration, and then we use the acceleration in a second follow-up question, right? Okay, so a train decelerates from this to this in 42 seconds, right? So that's the first part, right? So the initial is 35, right? The final is 22. Time is 42 seconds. Right, so let's find the acceleration. I'm going to use no x for that, right? So that's Vf is Vi plus At. Okay, so the final is 22. That equals 35 plus acceleration times 42, right? So let's subtract 35 from both sides. So 22 minus 35 is negative 13, so negative 13 equals 42a. And now let's divide both sides by 42. So divided by 42. And I get that a is negative 3.09523. I'll just write down. Whoops, that's not correct. It's negative 0.309238. Is my acceleration, right? And that's meters per second squared, right? Okay, so I'm going to use that in the second part here. The second part is here. I'm going to say, okay, this acceleration is negative 0.30923 meters per second squared, right? Okay, and then it says, in what time did it take to cover 98 meters from the beginning? So that's my displacement, is 98. From the beginning means that my initial velocity was 35, right? Right, and then it says what is the time it takes, right? Now, this one's especially cruel, okay? Because in order to use this equation, in order to use x as Vi t plus 1/2 At squared, okay? In order to use that, right, this guy's 98, this guy's 35 times t, right? That would be the one you would normally use, right? Plus 1/2, and then we know the acceleration is negative 0.309, right? That's quadratic, right? If you want to, do the quadratic equation, that's great, okay? I'm going to choose no quadratic for me today, okay? Okay, I'm going to choose to cop out of that, right? And basically my solution is going to involve finding this final velocity and then using V equals U plus AT. Okay, so Vf squared is Vi squared plus 2Ax, right? So let's see, let's find the final velocity. Okay, so here it is. Okay, so Vf is equal to the square root of 35 squared plus 2 times negative 0.30923 times, what is it, 98 meters? Okay, so I'm going to just type this into my calculator here. I'm going second square root, left parenthesis, 35 squared, plus 2 times the answer I just got. So I'm actually typing second answer, right? Times 98. Okay, right parenthesis, and I get the final velocity. It should be slower, 34.913. Well, that's not much slower, is it? Wow, is that right? I think it is right. Oh, whoops, hold on. I typed 9.8. Let's just try it again. Second entry. Let's get rid of that point there. 98. Okay. Oh, okay. Now this is messed up. Hold on. I've got it. Let's go there. Okay, so I'm just typing it. I'm having typing in issues. Okay, so negative 0.30923 times that, and I get 34.123. Okay. So 34.123 meters per second, right, is that final velocity. Now I'm all set. Now I can use Vf as Vi plus At, Okay, so I type in my 34.123 equals 35 plus 0.30923 times t, right? Okay, so let's subtract 35 from both sides, so minus 35, right? And I get negative 0.8768 equals, and that's negative 0.30923. So you now divide both sides by negative 0.309, right? So divided by negative 0.30923. Okay, I get 2.8355. Right, and the answer is 2.84 seconds. Okay, just be careful. I messed up the thing the first time, but it's obviously clear that you definitely don't want to round that too much, right? If you wrote 34.1, you'd be kind of way off, right? So carry a bunch of digits when you're doing that. That one's sort of tricky. Look at that. All right.